Welcome to week 4 of the Beginner Boost. That's right, week 4 of the Beginner Boost. It's already week 4. We are going to put the brakes on a little bit and back up. And this is actually, I'm just going to say right away, one of the things that I have always done in the Beginner Boost is I've adapted to the people that are in it, whether they're in person or they're around. And if you've watched any of the other Beginner Boosts from the last 4 or 5 years, you know that sometimes I'll just chop it and we won't do anything. Sometimes I've changed the language we were learning how to code in the middle of a semester once because they didn't want to do Java anymore. They wanted to go. So this is not uncommon. It does make people that are mostly people that are from the academic world get a little uncomfortable. So I've observed that the last week in particular, last week I did the boost, the 3-hour boost for week 3. And I'll just cut to the chase. I did it twice. The first time it was a little too complicated, so I redid it in the same day. Still ended up 3 hours long. At the end of it, I felt kind of uncomfortable because of how fast it went. And I realized now at the beginning of week 4, so if you've skipped week 2 or 3 and you're now on week 4, good. If you have noticed the quick start that I added this week, in order to get people going up and running fast, then you're kind of ahead. You may be already ahead. So the conclusion is that, and we will do Go, but it'll be something separate. So the criteria for the boost has always been somebody who's 9 to 19 or older, but somebody as young as 9, 10, 11, but definitely 12-year-olds, right? And we're talking generally about people who are outside of the curve in terms of ability, but we need to simplify this. So if you go back and look at week 3, week 3 and 2 were too hard. So just restart with me today, and we're going to do it again. And I'm going to pretend like you know nothing more than you got Podman on the machine. You've got your terminal on there. You probably struggled a little bit to get Podman Desktop to run. I still think Podman Desktop is the fastest way to get that. And if you have any question as of this moment about whether you're ready to proceed with week 4, go back, and if you go to the YouTube thing here, if you go to our YouTube channel, you'll see, where is it? YouTube, your channel. So what I want you to see right away, actually, I put this new video at the top of the boost so that you could see it. This is the quick start, right? So, you could get away with watching week 0 and week 1. In fact, you could get away without watching any of that and just come and jump right into the quick start and get really moving. Now, I would appreciate you watching week 0 because that talks about, the purpose of it and why we're here and everything. And I think it's important. But if you just want to, get to the guts of it, you can just do the quick start. So let me recap. We have created a quick start, which is 40 minutes long, which takes you into how to, what terminal software to get, how to install Bash, how to install Podman Desktop. It doesn't show you how, but it tells you what you need to do. And then it tells you how to pull and run a SKILSTAK image. And we're going to start week 4 with that today. Okay, so the assumption going into this, and this is very important, the assumption going into this is that you have got Windows or Mac, you've got a terminal installed, either iTerm 2 or Microsoft Windows Preview, that you have installed Bash, that you have Git Bash or Bash from Brew with Mac, that you have installed Podman Desktop successfully and WSL2 to support it if you're in Windows, and that you have now customized your terminal and you know how to open a terminal, and you can see basically what I see here, right? So those are the things. Stop the video right now if you don't know how to do that. If you haven't done those things, go watch the quick start and make sure you can do everything in that quick start, okay? And to be fair, that is the only assumption we are going to make about going forward. And so you can pretend kind of like you went from quick start to week 4 if you wanted to. But the other stuff, we didn't. It's harder. You're not going to lose anything by having gone through those other weeks. But if those weeks seemed exceptionally hard for you, I'm sorry about that. But that was based on the fact that, we made some assumptions about you, about what you know and stuff like that. So we're going to regroup and start with week 4. All right. So the first thing to do here is to start a new. We're gonna click on the plus in Windows Terminal. You're gonna start yourself a new terminal. If you don't get Bash terminal, you should have changed it to so that's your default. But otherwise, you do the thing and you go to Windows Get Bash and you run up Get Bash. We've talked previously about why Get Bash in the startup. It's mostly so that you have Bash on Windows. That's covered in the quick start. So this is where you are, okay? And then the first command that you're going to execute, and this, you only have to execute this one time, okay? And if I were you, I would actually cut and paste it from the notes if that makes you more comfortable, okay? It is a complicated command. This is probably the hardest part of the boost, but it's super important that you do this. What this will do is it will create Linux for you to work on, right? And that it's a Linux container for the boost, and it's going to use the one from SKILSTAK that we've prepared for you, and it's going to share a drive so that you can copy files over back and forth to it. Okay, that's it, right? And so if you go back over here and if you F11, you can go back and forth with Control Tab if you want to. You can do Control Tab if you want. So then we're going to right click and we're going to install this. Now I think I have one already, so it'll probably give me an error. Yeah, so yours should work right away. All right. Now once you have that, you should be able to do podman ps-a, and you can see it, and you can see mine's there on the bottom. I've got a lot of other ones, right? But the important thing is that its name is Boost. Okay, the important thing is that its name is Boost. All right. So once again, the thing that's changed from last week to now is that I was going to have you build your own Linux distro, and now we're just going to use an existing Linux distro, right? And so let's go ahead and attach to that. So podman, and you'll be doing this a lot, right? Start-a boost. Okay. Now, what is super important here is that you don't delete it. You can reboot your computer, that's fine, but you just don't delete that container. So 2 years ago when we used containers, we didn't even really talk about it. We just assumed that container is going to be around forever. I'm just going to say that because containers are not necessarily designed to be persistent. They're not, the general thinking is that you should not, think a container is going to be around forever. Right. So when you create a new container from an image, in this case, ws-skillstack, you get a container that, is temporary, but won't go away until you delete it. So if you uninstall Podman for some reason, or if you, if you explicitly delete that container or you purge or something, any of these things while you're experimenting, your container will go away. So be careful. Okay. Because some of the things you're going to do you're going to want to do from week to week. You're going to be building up on those things. Now, to be fair, we are going to get to the place where if you happen to delete your container, it's not going to be that big of a deal. In fact, by the end of the boost, you should have anything that you've customized in your Git repo, so in a .files directory, so that you can pull it down and recreate it anytime, so that you don't have to worry about the container going away, right? If the container did go away, you can come in and put it. That's the whole point, right? Is to centralize your customizations into some other place. Okay, so I'm going to go ahead and attach to it. So here I am. I'm attached. So let me just talk about this for a second. So right away, you're going to see the same prompt that we've already talked about in week 1, I believe. We see the user, we see the host name, SKILSTAK, and we see what directory we are, our location. The tilde means home. We've talked about that. And we see that we are a user. So we have the $sign. Okay. Now, just for the sake of reference, I want to show you how to get to root. Okay. We're not going to need root right away. But if you wanted to be root, you would do sudo su- enter, and it'll ask you for the password, which is password. You can change that if you want later, but and now you have a root prompt. So I just wanted to talk to you about the different sort of modes and users that are on this basic image. Okay, so we have, when we change into root, we have the root or the admin user that has, super user permissions. We have the same host, and we have a hashtag here that's red, which says, oh no, okay, everything I do now, I'm going to do as root. So things are much more dangerous, right? That's why it's all red. If you wanted to go out of that root access, you would do this. But the reason for that is so that you can go back and forth. So that is the only sudo su command that you are going to use for now, and we will not be going into the sudo command in depth. We're not even going to go into user, anything besides user. In fact, I wanted to talk about this for a second. So we talked about what is a command line, what concepts does the user need to begin to understand. So let's go through this really quickly. What does it mean to be a Linux user versus an admin? So that's what I'm trying to show you here. Okay, so this is a Linux user. Everything's happy. You can't really break anything. You are a user in a protected space, even on the same system. If you had multiple users, we don't right now, but that's what it means to be a user. What does it mean to be an admin? An admin is somebody who can, mess with the setup of the computer and the distribution, right? An administrator, a system administrator, or a sysadmin. And there's been so many jokes about system administrators in the past, because usually you had to bow down to them and stuff like that. So, but you've got root when you need it. Now, what I'm going to repeat is that you do not need to be an admin for the most part on this machine for the scope of the boost. And one of the ways that I think that this year's boost got a little bit off the rails is that we started assuming that you wanted to be an admin, right? And really what we need to teach you first, what you need to learn first, is how to be a user. All right, so we're going to change with week 4, and we're going to assume that you already have Linux and you have a user account, and you just want to know how to use it. You just want to be able to customize it. You need to know how to navigate it. You need to know those things. So what are the concepts that all users need to know, right? And I mean, you got it, and I've put some questions here to get us started, but you just need to know how to use the Linux system, right? How do you attach to it? We've already covered that with Podman. But more importantly, how do you get around? How do you make files? How do you edit files? What are files? What are directories? What does the prompt mean? How do I write some code and actually get it to work? How can I do research? How can I find things that I might have lost? What does it mean to be a hidden file? I mean, these are all user land kind of issues. And when I said again that I think that the 2023 boost got a little bit off the rails, is we started to do administrator stuff. We started to do stuff that requires you to have a more advanced knowledge of Linux, because we wanted you to learn Linux properly, which means learning how to run Linux from your machine, your personal local laptop or tower that you have control over, right? Not having any internet access dependency, so you can actually get going and start using it right away. And the reason that we're regrouping here is because on the internet, if you were to go learn Linux, what they would do is they would dump you into a web page that's a terminal emulator, and you would immediately start doing things as a user. They wouldn't set anything up for you. They wouldn't really talk to you about the organization of the files and the overall operating system. They wouldn't do any of that. They would just get you running as a user, and they would start with those basic commands. So in 2024, the boost will start here. Okay, and then the entire boost is going to be involved. Going to involve customization of your account, learning how to understand the files that were created for you, so that you can modify them and mess with them, and without fear. And then eventually, how you can take that knowledge and start coding. We want to do a little bit of that, and then in another segment, probably Home Lab Init, you can start learning the things about Linux, like what is the Linux file system about? What are, how do I hack it? How do I set it up? How do I put it on my own machine, my own server? Okay, those are things that are outside of the scope of the boost. All right, so if you're mad that we're going back to the easy stuff, GHCR in your URL, is it GHCR? No, it's GHCR, yeah. GHCR. Somebody's asking a question. You block this page. If you block the page, it's because you're running a container registry. So, yeah, some people had some question about the URL. If you want to see the image, you go to github.com rbxrob/ws.skills-skillstack. Okay, so this is the container, right? And here's the thing about how to install it. Oh, he had to type in URL. Okay, gotcha. All right, everybody. We're back to doing some stuff here. We have, how much time do we got? We got another, I don't know. Let's keep going. So, what is a command line? We've talked about that. A command line is a place where you enter commands. That's what this is. It's different than a terminal UI, because a terminal UI is something that you can run all kinds of things on. So let me give you an example. Neo. If you run Neo, you can see this is kind of like a matrix-like thing, right? This is called a terminal application or a terminal UI because it uses all of the terminal, right? And then you have a command line application, which would be something like BC, which is a calculator. And then you could type, 3 plus 5, enter, and you get a number out, right? And that's still kind of a terminal application because it kind of took over control of your terminal. Type quit to get out. And so the difference between a command line is where we have this read, evaluate, print loop, right? And a terminal application is something that takes the whole terminal and uses it all up. And those are some of the applications so that's the difference between a terminal and a command line. And then I've already used a few commands, so let's go through and review those commands. I didn't want to put them here because I didn't want to give away the answers. But how do we clear the screen, right? So a lot of people will tell you to use Control L. Notice that it does not work here. And that's for a reason. This particular Linux container has been set up to use VI navigation, which we're going to get into later. You should never depend on Control L to clear your screen. The command to clear your screen is clear. In this particular case, the C command is also an alias for it, so you can just use C to clear your screen. Okay, so you can pause it there. How do I see stuff? Okay, so let's actually list out the stuff that's on the screen, that's in this location, right? So, so the first one here, actually, let's do. I'm going to go ahead and put the answers here. Clear or C. Now, C is an alias, but it will always work on the image that you're on, right? And I'm going to put here. Do not depend on Control L. Okay, so some people do that. I'm going to put that there. I've never used reset. Reset is for a TTY. So yeah, is TTY reset. Yeah, you don't need to do that. If your terminal ever gets messed up, you could. Yeah. What is reset? I don't know. Somebody asked about reset. I don't ever use reset other than if I mess up my terminal. Yeah. So, yeah, Ultimate Dev TTY. Yeah. So you don't need reset. Most users won't need it, but that's another one you could definitely. If you screw up your terminal somehow, most people are at this level are going to shut their terminal, open a new one. But yeah, okay. So a couple of other things to keep in mind. Um, so how do I clear the screen? Let's talk about that. How do I see stuff? See where I am. How about that? How do you see where you are? So I'm going to go through these a little bit faster because there's a lot of them. How do you see where you are, everybody? So pwd will print a working directory. Yep. I just script terminal. No, don't do that. So pwd. So this shows you where you are. You can see you're in the home directory. We are not going to get into the long-winded conversation I did twice last week about what everything is and where it is. Okay, all you need to know is that your home is in home user and your name is user. Okay, and so then let's go back to so here we go. We can see where you are as pwd. So that's how you do that. How do I see what is in this directory? Okay, so what is a directory and what's a file? Let's talk about that. So what is a directory and what is a file? We already talked about this. I don't want to do it again, but I'm going to do it fast. Okay, so if everything in Unix is a file, okay, Unix and Linux is a file. So so you can do ls to see everything, but you can see there's not everything here, right? So let's do ls-a, and that'll show us all the files. Okay, so that's the answer to that one. So, but what is a directory and what is a file? How do I see what is in this directory? Okay, so let's do ls-a. You can also do, you know, again, any of these commands you can read about. I think that goes without saying. So you can do man ls, right, to look about it. How do I get, how about this? We already did this one, but I'm going to do it again. How do I get help information about a command? Okay, so there's the command, right? Command name, command -h, or command -help, right? Or there's like man, and then cmd, right? And on occasion it's help cmd, but it's, when that happens, it's actually not a command, it's a subcommand of bash, but you don't need really to care about that. We're not going to use pushd and popd. Nope. Okay, so let's do that. Okay, so here we saw man, and you'll notice it's colored and everything, and I'll show you how to set that up, but we're not using apropos. Apropos is, yeah, no apropos. Apropos is not very good. So, I mean, if you want to use it, you can. I don't ever use it. The problem is that it's the man pages. Apropos is almost never covered. So like the apropos is, you know what? Okay, fine. I'll put it there. Apropos keyword if you want. I don't ever use it. I find searching the internet faster than that usually. I don't even know what tilde is, and we're not even going to talk about it. That's not stuff that's on Unix. Okay, so these are all the ways to get a different help. You can go read about it. What is a directory and what is a file? So let's talk about that for a second. I feel like we need to start talking about how to cancel like a command line. So let's do that. Let's see if we can cover that. what are the, let's see, how do I work with my command line? Yeah, actually, no, that's processes. We'll do processes next week. All right, so what is the directory and what is a file? So you probably know this already, right? But if you do ls-a, you can see there are a bunch of files here. If you do ls-al, it'll make a long listing of them. Yeah, and you can try, if you do man ls, you can read all about it. So here we've got the different types of files here. And we're not going to talk about permissions right away. We'll get into, we'll probably talk about it at the end of today, but not the thing. You can see that there are a couple of these that have a D here or that they're blue. Those are directories, okay? And then, let's see. Let's talk about this. What is a directory file? What is a parent directory? Yeah, parent and subdirectory. All right, so they are the ones that have dot and dot dot. Okay, so the dot means the current directory. We covered this already last week, but whatever. Dot is the current directory. Dot dot is the parent directory. All right, and yeah, we need, okay, so ls-al, and you'll do it again. We type C, clear the screen, ls-al. So we see a dot, that means this directory right here. And we see dot dot, which means the directory above here. And in fact, you can actually add these to the command. So you could actually al dot dot, and now it will list what's above it, right? And if you go, I mean, that's the home directory as we noticed, right? So we have the user, we're currently in user, but if you put dot dot, then it chops off that one and it does this one, right? So it does the home there. It's at the top. I apologize for this. It's so remedial, but I want it to be remedial. I want it to be that kind of thing. So how do I change directories? Okay, so the command for this is cd. All right. So, and then directory. Okay. And let's try that. So pwd clear ls ls-al. Let's cd into the .config directory, shall we? So cd.config, enter, right? Okay, and then so how about this? How do I change into a directory? There you go. Cd dot. You can also do cd dash, and what that will do is that'll change back to the previous directory. There you go. Okay. So if you do cd dash, it'll go back, and you'll see where you are. Okay. You'll see me do that all the time, by the way, if you watch me stream. I'm always constantly typing cd and pwd just to get a sense of where I am, even though it's already in the prompt. This tells you what directory you're in, but it doesn't tell you the full path to the directory, so you can look at it there. Okay, so that is it. If you wanted to change into the upper directory, you do cd dot dot, right? So cd dot dot takes you up. Now, how is that different than dash, right? Same thing, except for if I want to go all the way into the root directory, I could do cd dot dot pwd, and now you see that I'm there. Cd dash takes me back, right? If I wanted to go up 2 directories, I could do that. Cd dot dot slash dot dot. And now you'll see, wow, I'm all the way at the root, right? And I go back to where I was with cd dash if I want. If you get lost, right? So let's say you're like lost somewhere and you want to go back home, you can always just do cd enter. Okay, a lot of veterans don't know this. The default for cd is home. And there's a lot of, including me, up until like 5 years ago, that they'll do the extra work to type the tilde you don't need to. So cd on every Unix system by default will put you into the home directory. Okay, so that's kind of nice to know. So just CD will default to the home directory. So if you get lost, that's a way to get back home. And there are other commands related to directories, but they're usually more used for scripting. Again, this is for absolute baseline beginner users. So that is what you can do. You can see that the slashes separate the different directories. That goes without saying. They are forward slashes, not backslashes, and that's super important if you're on a Windows machine. In fact, that's one of the reasons we put Git Bash on Windows, is so that you can get around the problem with backslashes by using forward slashes and have something consistent, rather than having to switch mental states every time you're working with the Windows file system. But and of course, Bash on Mac is already, or Mac in general is just already fixed because it's using Unix. All right, so how do I see what's in a file? Let's do that one for a bit. Okay, so the obvious thing to do here is cat. So cat stands for concatenate. All of these commands you can read about by doing man, right? We're not doing that right now because I want to get through them and I want to make sure you know which ones to cover. So you just do cat and then the file, right? Now, can you cat a directory? Can you cat a directory? Probably not. So let's look at, I don't know. Let's look at what is in the vimrc file. .vimrc. I don't know why that's executable. That's weird. Yeah, it should not necessarily be executable. That's a bug. Anyway, so wow, oh my gosh, look at, there's lots of stuff in there, right? Now you see how it went off the screen, and you can scroll up, and you can, I'm using my mouse. One of the few times you'll see me use the mouse. You can scroll up with the mouse and you can see all the stuff that's in here, right? And this is, by the way, this is my vimrc. So I think I've got most of the stuff that's just for me out of here, but and we're actually going to go through the vimrc later, and we're going to briefly talk about what everything in here does so that you can understand it. But as a user, you just have to accept that a lot of these configuration files, you're going to use them. And that's how I did it. Most people don't start with a perfect, system that's been all customized. They start with configurations that have come from other people, either through copying and pasting from those other people, or they were already been set up on the system, as is in this case. So there's no shame there going through that. So I don't know if you saw, but when we catted out that file, it went way off the screen, right? So in order to see a file, the thing about this is a cat a file, but you can also have another file, right? You can have like multiple files. So that will cat two files together if you want to. Let me see if I can make a thing here. So echo sum to temp foo, echo thing to, we're gonna learn how to do this, to bar, and then we do cat temp foo. Well, we could do this, temp foo bar. And then you see that it puts those two files together. Now that is, we haven't learned that yet, but you will. So that's the same as this. And you see that it puts the two files together. If you were to do just one or the other, and that if we're going to show you cat, I want to show you a true use of cat. People misuse cat all the time when they should be using file indirection, which we'll talk about later. So it says cat, but as I said, you can't see the whole thing, right? So you want to use what's called a pager, and in this case, we're going to use, there's two pagers, there's more and there's less. Okay, the reason I'm telling you about both of them is because more is on more Unix systems. It dates back all the way to the original, but it is significantly inhibited compared to less. Less has got a lot more going on. I know that was weird to say, but that's true. So you can do this. You can say ls-l, ls-a. Let's look at them all. Okay, so that vimrc, right? So let's try it with more. Actually, which more are we using? Yeah, okay. So more.vimrc. And now you can see it doesn't really give you a lot of information down at the bottom, but it definitely is stopped. It stopped. It pages, right? So every time you push, space, it pages and it goes down. I think, more has arrow support. So if you want to go up and down with the arrows, you can. There's ways to page it one page at a time, but most of the time you just do this. If you want to find something in here, and I do this all the time, if you want to find something in here, I usually always open it and then put slash. So let's say I want to look for some Perl code in here. Where did I put that Perl code? So I did slash enter, and then that jumped to Perl, right? If I push N to go find it again, it'll find the next one, and the next one, and the next one. And that kind of behavior is pretty standard, right? So it's just jumping through the file to the next thing, right? So it's very common to type a slash with your keyword and then N to go find it. If you do a capital N, it'll go do a reverse search. Okay, so but let's do less, and you can see how much more less is. All right, so less is basically the same thing. In fact, I think less than, let me say something. I think my more is less. Yeah, it is already. All right, so on this particular system, and this is not uncommon, right? The more program itself has been aliased to less. And let me actually show you exactly. So when those two things I just showed you, they were both using less. Let's try this. Let's actually force it to be user bin more. Just so you can see. Okay, yeah, here we go. So this is what more looks like. It doesn't have the color. It's a little bit weirder, and you can still find the Perl, but it doesn't highlight it for you. There's a number of other issues with more, but it's important that you know that both of them exist. Okay, so but when I did more, it actually used less because of an alias, which you'll learn about. So here we go. Right. So when we do man ls, by the way, it's also using a pager automatically, and that's where the colors are coming from, by the way. So it's able to go, and it's telling you what line you're on, and stuff like that. Okay, so it's very important that you learn how to use pager, specifically more. And cat, you'll need to use it a little bit, but not a lot. Sometimes it's nice if you have like a nice short file. All right, so we know how to look at what's in a file. We're gonna see. Okay, so let's just see this. How can I determine? I don't know if we want to go into file types right now. How can I create a new file? How do I append a file? And how do I edit a file? Editing the files, we're probably going to have to save that for next week. So let's do this. Let's say, how can I, let's see, how can I tell what type of file it is? Okay, so for this, we're going to use, so we're going to use, let's use head and tail. Thank you for the reminder. So if you want to just look at the beginning of a file or the end of a file, and by the way, there's also tac. A lot of people don't know about this. So let's go ahead and use tac too. So I know I'm kind of just pulling this out, but that's fine. So let's do that. So let's say ls-al. Watch this though. This is kind of funny. tac.vimrc. Okay, so this is the first line of the file, right? And now it's the thing. So head and tail. Let me show you. Head vimrc. We'll show you the top of the file. So head.vimrc. It shows you the top. You can look at the bottom of. If you only want to look at the first line, I use all the time. -1, and you can read more about that from manhead there. You can go read about it. Lots of powerful things there. Again, the boost is just designed to help you as a user to learn the basics, right? So you can look at the first line. If you want to look at the last line, you can tail -1 vimrc, and it'll show you the last line of the file, right? So there is no such thing as +1 in head or tail. It's kind of weird. So let me show you. So with no fire or when file is dashed, read the standard input. We're not going to do standard input yet. Okay, here we go. You can do the number of bytes. You can do follow, so it'll keep writing. Where is the? It's just dash. Dash is just. I mean, that's been around forever. I don't even know why. I've used to just use it. So the dash is the number. You can't do 1 because it's like it doesn't see it as a number. If you put a dash, it just automatically assumes that's a number. Does it do? No. Oh, okay. +1 is from the. Oh, no. +1 will give you the whole file from that position down. Yeah. Yeah. I mean, you can play with it, read about it. I don't use. Look, for a lot of these commands, you really don't need all those fancy things. You just need the basics, right? And I very rarely do anything more than that. So if you do 2, it'll give you 2 lines. There's one that'll give you context. I have a feeling though that if we do plus, it'll skip over. I don't know. Let's try. And then we haven't learned pipes yet, but we'll learn this. So pipe that to more or less. And no, it didn't do it. No, it did. It did. It did. I think it did. Yeah, let's try it like this. Oh wait, no, that was a tail. That was a tail. Invitation is the pipe. Yeah, we're gonna do pipes next. Okay, so we need to introduce pipes. So let's do that. Okay, so what is a pipe? And it's actually, I mean, we call it a pipe, but I could spend 20 minutes just talking about the definitions of what a pipe is and getting in deep and dirty into the Linux stuff. And we're not going to talk about everything in /proc. We're not talking about anything there. We're not doing that. Okay. I got sucked into talking about advanced non-user stuff last week. I'm not doing it again. So what is a pipe? Okay. So the pipe is just a way of combining one thing with something else, right? So if we do ls-al, and that's kind of big. So let's say that went off the screen, right? Wouldn't it be nice if we could get it to page stuff, right? So how would we even do that, right? And let me deliver. I'm artificially going to make. Don't do this, but I'm going to artificially make this kind of broken. So if I do ls-al, you'll see that, oh no, I can't see everything that's there, right? So wouldn't it be nice if I could combine the output with one of those pagers so that I could use the pager? And this is where pipes come in. No, Frank, everything you've suggested is completely not basic user stuff. So you can stop recommending advanced stuff. Yeah, your suggestions are not current for this scope. And I'm not going to be pulled. People like you got me off track last week, so I'm not doing it again. So we have, just so you know, everybody, we have wonderful, well-meaning people in our chat who are very advanced, who are recommending all the most powerful, awesome commands, and they keep forgetting that you've never even used Linux before. And I did too, and I want to stay with the simple stuff. Okay, so ls-al, that shows me everything that's in here, and we're going to go through what each one of those fields mean, but not right now. So we're not going to go through that, by the way, until we get to script writing, when we start to actually write stuff that runs, and we'll talk deeply about permissions and ownership and all of that. Okay, so ls-al, and then we say I want to send that to more or less. Now my fingers have got more baked into them. That's why I set an alias for less to from more to less. But you can send that to less. Now you can see we have our happy pager. In fact, we could even search it. We can search for the output there in just using the pager, right? So we don't even need other commands for doing that kind of filtering and stuff. So we can go through and search for that, right? And we can type Q for exiting that. Again, if you want to get all the details, you can go man less, and you can read all about it, right, by looking at all these commands if you forget them. But once again, so I deliberately forced a tiny screen so that you can see that you can use a pager to tab through the stuff that's there. Now let's go back to a wider screen. I'll unsplit my screen, and we now have, with C to clear the screen. So we have gone through how to pipe. So what a pipe is, you could put, we should put, I mean, that's just to see what's in a file, right? What is a pipe? Okay, so a pipe is something like ls-al pipe to more. So this is the pipe. Right now, you can have a lot of pipes combined. You can have piping going from one to the other, and so on. So let's talk about the exact names for the stuff that's involved in a pipe. Now this is going to be part of redirection, right? What is a pipe? Okay, so when we're dealing with pipes, we're talking about redirecting, right? Well, so this is what a pipe is, but in order to understand pipes, you need to understand the different streams of output and input. Okay, so something called file descriptor. What is a file descriptor? And this sounds like it's not beginner stuff, but it kind of is. And how do I use them? Okay, so strictly speaking, a file descriptor is anything that points to a file in the system, all right? But the only ones that you really care about are something called standard error, standard output, standard input, and these are in every computer. And pretty much standard error. All right. Okay. So, otherwise known as stud-in. They're going to hear people talking about this. And stud. This seems advanced. It seems like, well, I don't need to know this as a user, but you actually do, and let me tell you why. Okay. And when we come back to scripting, you're going to be using it all the time. So, standard error, standard output, and standard input. Okay. Yeah. So yeah, everything is a file. Okay. So, and these actually have numbers, but I don't know if I'm kind of hesitating whether to tell you about that yet. So standard input, if you can think of it like this, you can think of it as sort of a stream of everything that you're typing, right? And I actually kind of want to do this part. Yeah. So I don't know if we should do it this week. I think we should do it this week. What time is it? Okay. I think we should do it this week, but I think we should end with it because I want you to understand what all of this stuff, how it was inspired, because it will help you understand what's actually going on. Okay. So that you can like visualize what's happening. And in fact, I think I'm going to go jump right into it right now. And so we're going to say this, understanding origins of TTY. Okay. Now, this is like a little history lesson that we have to do. It's really fun, but some of you are going to find it extremely boring. But when I tell you about the history of this thing called the TTY, everything will become clear, and you'll be able to use it as a metaphor for everything else, because it is the metaphor for everything else. All right. So we're going to have a little bit of story time. I'm actually going to pause the video right now temporarily. I'm going to go get a drink, and I'm going to give you about a 10 or 15 minute history lesson about Linux command line and the TTY and everything that you need to know about the terminal and where it comes from. Okay. So let's do a pause. Let's do a break. Go. Okay. So I actually have a little glass of wine here at like 1 o'clock in the afternoon. We're headed off to a party, my wife and I, later today. Baby shower. I'm super happy about that. But let's do a little bit of story time. And you know, Linux can be really dry. And I often forget when I'm streaming that I'm still dealing with people that want to have something interesting. So I want to encourage you to go do a search for this right now, just for fun. And this will not be time wasted, I promise. Search for teletype. All right. Now, there's going to be many of you out there that are going to be, what the hell is a teletype? Right? And you're going to be like, what the heck does this have to do with me learning Linux and everything? And, you know, if you are really focused on, I just want to get the guts of the details, fine, jump ahead and learn the commands. But if you truly want to understand how the command line works in every Unix and Linux operating system, and frankly, PowerShell and anything else, this is the origin of the command line. This is where it came from. I'm going to spend 5 or 10 minutes talking about this. I actually really enjoy talking about this. So if you've ever used a typewriter, and some of you don't even know what a typewriter is, you don't remember how we used to do input, right? Royal typewriter. This is the kind of typewriter that I learned to type on when I was 8. In fact, I still have it somewhere. It's worth, I don't know how much money now. But this is how people used to enter in stuff. And this is where the QWERTY keyboard comes from, QWERTY right there. This is how people used to enter information into the terminal. So if we're going to have a Linux, command line terminal beginner boost, we cannot have it without talking about the origins of human computer interfaces. And that's what this is. So these days we're using, voice activated interfaces and all that stuff. And the topic of human computer interaction is something that I obsess with. I really, really love it. But it started with the typewriter. Actually, before the typewriter, there were, punch cards and stuff, which we will get into when we talk about binary later. But this is how it all started, right? So a long time ago, in fact, the original term for a computer was a person who manipulated the computer. I mean, who computed numbers, right? It was largely people that were largely female, and they were sitting there with computer numbers. We'll talk about that again too when we get into it. But these people had to figure out how to put data into things more quickly. I'm watching a documentary on Pearl Harbor right now, and they were all doing We're going to talk about that again later. But what you need to take away from this today, right now, is that this is the origin of the terminal in Linux and Unix. In fact, to date, when we installed a terminal, what we're actually installing is a terminal emulator. People have dropped the term emulator, decades ago. We don't say terminal emulator anymore. We just call it a terminal, right? But the truth is that in the old days, a terminal was something that terminated. It was a thing that you communicated with. And so we have these terminals, right? These were the original terminals, and they were a step up from Morse code and that kind of thing, ... and that kind of thing. But still, they had to be typed into, and so when you interacted with a computer back then, and they were a step up from punch cards, as I said. But as you can see, you had a keyboard, and you typed on the keyboard, and then you didn't have a screen. You had paper, right? And so you would see the paper come up, and you would every time you would type something, it would go and it would do its paper. So the reason this is important is because every single thing that impacts how you use the command line in the terminal comes from this original idea of the teletype machine. Okay, and that's all I'll say about it. You can go in and read about them, and they're super fun. It's a great rabbit hole to go down if you want to study all that stuff. And if you if you want to learn the origins of the QWERTY layout, I mean, these are really cool things to read about if you're geek out. I'm not going to overly burden you with that, but I want you to know that that is where the term teletype comes from. And to date, the screen thing that you see that's being drawn to, that all the letters and everything are appearing on, whether it be fishies or words, is still to this day called a TTY. And that TTY stands for teletype. That's what it originally was. So you can still see that even today. And in fact, if you go out on the system, you can go see a bunch of these TTYs, right? So if you do ls/dev, you'll see, hey, look, there's a device there called a TTY, right? And you'll see a few other things in here. These are special files, and we won't get into them too much, but you'll see these other names that we talked about, right? You see standard error, standard input, and standard output, right? So if you think in terms of the teletype machine, then you can think in terms of the streams of data, or where was data being entered and written to. All right. So the stream of data that was going in is called standard input, and that was specifically what you were typing, right? That would come in. And by the way, when you type on the keyboard, it wouldn't send it all right away. It wouldn't send it until you hit enter. In fact, back then, I think there were some keys that weren't even just the word enter on there, but that was the thing where you said, okay, I'm committed now. And you hit enter, and then that would send that stream of data in to the system, into the machine. And that to date is called standard input. So every time you type something, you are typing something into standard input, right? Now, when you type it into the TTY, it's complicated, but the TTY is actually echoing back to you immediately what you just typed, so you can see it. And that's where the term echo comes from, right? So when you're typing, you're actually sending input, but at the same time getting it right back. But it doesn't send it to the shell to commit it until you hit enter, and then it sends all of it, off to whatever it is that's processing it. So these concepts of standard input and standard output and standard error. Let's talk about the difference between standard output and standard error for a second. Okay, so standard output is the main output. So when you print something, and let's practice that, echo, you can learn echo right now. So you can say echo something, and you can see that it writes that thing to standard output, which appears on the screen. Okay, so it's important that you know that the stuff that gets written to the screen is both standard output and standard error. Both of them get written to the screen. And Mr. Rob, well, why do you have a standard error and a standard out? The reason is so that when people are writing programs, they can write programs that produce output that's intended for use, the main stuff. And then all of the other warnings and everything, those can go someplace else, right? And those go to standard error. And so the reason for that is so that you can distinguish between the errors and the actual output, right? And this is super important as a programmer later. There are so many people who have written crappy programs that do not distinguish this output. And so it all goes to standard output, and that leaves you as an end user, with a problem, because now you have to decide, well, what stuff is important and what isn't. So as a matter of course, the important stuff that the user needs to know about goes to standard output. And the unimportant, error messages or important error messages, they go to standard error. Okay, and those are different, streams or file descriptors is the official term. And so anytime you write to a file descriptor that has one of those names or numbers, and somebody reminded me of the numbers. Let's go ahead and add them. So the number for standard input is 1. I think, did I get this right? Did I get it right? I always have to look it up again. I know 1 is standard input, and then there's standard output, and 2 is standard output. And so on occasion you might need to know the numbers, and we'll get into this in a second what that means, right? So the file descriptor 1 is always standard input, file descriptor 2 is always standard output, and file descriptor 3 is always standard error. And that'll make more sense when we get into everything as a file, when we do a little bit of scripting. Okay, so now this has to come up when we talk about pipes, because beyond piping, so what is this pipe by default, right? This pipe that we did earlier redirects the standard output through the pipe. Okay, and this is not this feels like not beginner content, but it absolutely is beginner Linux content. So I have to include it. Okay. I'll try to make it as simple as I can, but you can imagine, every time you think about standard error and standard output, imagine if you had two teletype machines, right? Or if you had a teletype machine that had three parts. It had a keyboard you could type in, and it had one amount of paper that was all of the standard output stuff, and it had another roll of paper for all the errors. And the errors would get written over here, and then all of your main stuff would go out to the main output screen, right? And your input would be the same, even though there would be like one running program to handle all of that. Okay, so you can kind of visualize those two things separately when we're going through it. And yeah, I gotta avoid questions right now. Those are some great questions though. So everything about the command line and about the Unix way, Unix and Linux way, involves something to do with one of these three pipes. Okay, now every file also has a file descriptor. Okay, so you don't need to get into what their numbers are, but they also have a file descriptor, right? So you can write to those things. So let's talk about redirection and pipes. So a pipe is when you redirect the output instead of it going to the screen, which is the default. So you could say the default file descriptor for all commands is what? 2, right? The default is 2, I'm pretty sure. And I thought it was 0, 1, 2 myself. Somebody was saying it's 1, 2, 3. I think this is wrong, actually. I think this is wrong. Yeah, I think it's 0, 1, 2. Yeah, you know what? I doubted that when you put that, Frank, and then I like, okay. No, it's 0, 1, 2. The actual numbers are 0, 1, and 2. So and because I know that because of the TTY. So I need to take a second here. So let me show you. So if you're a beginner, please don't freak out right now. All right, I just want to go look at the redirection. Commands for bash RC function is set file. Oh, that's weird. Oh, that's because of the rainbow. Okay. No, that's not it. Yeah. Yeah, it's yeah. No, it's 0. It's 0, 1, and 2 because I know because of the -2. Yeah. Give me a second here. Yep. Boop 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 boop. T, because we did it in the other. We did a detection. Yeah, TTY-0. So this is why you want -T. File descriptor is as open as a terminal. Yeah. Yeah, 0, 1, 2 is correct. Okay. Alrighty. So I'm sorry we got a little bit our wires crossed there. I had some people in the chat. But so it's 0, 1, and 2. And so anyway, so the default for all output is 1. Right? And this is happening. So anytime you do ls-al, it prints to file descriptor 1 or standard output, right? And that actually is a device on the machine, which will in /dev, but I don't want to go there right because you'll get confused right now. So, but we want to say, hey, I want to send that output someplace else, right? You can say, I want to send it to another program. And when you want to send it to another program, it's called a pipe. So you put this bar there, and then it sends that output, the default standard output, to that, right? Now, here's something interesting. If it had created errors, would those errors have gone into more? No, they wouldn't, right? And we'll show that a little bit later. So what we need to talk about right now that's related to pipes is what's called indirection. And I don't know an easy way to jump into here, so I'm just going to jump in. What is file indirection, I guess, or redirection, indirection. I've heard it called lots of different things, right? So there are a number of ways to take the output the standard output and the standard error, and to say I want to redirect that output someplace else. Okay, so you could do it like this. You could do ls-al, and you could redirect that into temp foo, and that'll put that into a file. All right, and that is, this redirects the standard output into a file. All right, so that's all you need to know. And I'm gonna fight really hard to get all of the different complex ways of doing this. I don't think beginners need to know them right away. So we're going to try really hard to keep this simple. So this just says, instead of taking, how do I append to a file? All right, let's do that. Okay. What is the pipe? How do I write output? How do I write output of a command to a file? All right. So this is not appending. This is just writing it to the file. And this uses redirection or indirection. So you take ls-al, and then it says write whatever comes out of that. And, it kind of looks like an arrow. And you can do that. So ls-al, and then I temp foo. Now the thing you need to know about that is that that's going to overwrite the file, right? So if I do another command, echo hello there, and I write that to temp foo, you'll see, let's cat temp foo. You'll see that temp foo has hello there in it now, right? Now there is a way to stop that, but that is the most common way that you are going to blow away something you're working on, is by overwriting an existing file using a command that you didn't expect. There is a way to override that, but it's not currently set. It's called no clobber, but you need to get good at not doing that. So this is the time for you to make those mistakes if you're going to make them. Okay. So now when we cat that file, we see it's got the output of the command in it. And now it's like a way to save the command, so I can cat that file anytime I want, and I can see what's in the command. Okay. So that is how to write the output of a command to a file. All right. And I'm going to try to keep the language simple. How about this? Let's do another one. How do I append command output to end of a file? Okay. So that is, you could say echo sum, and you use two of these, right? Temp foo. And you can say echo thing. Actually, those are not. This is going to be hard because these are not going to. I'm not going to be able to put these letters in the HTML in the notes because stupid YouTube. Echo thing to temp foo. It's not. It's going to complain about them. I can't do. I'm going to have to escape them or something. So this is the append operator. And what that does is it takes whatever comes out of this and it puts it at the end of the file. All right. So you can say echo sum. Actually, no. Let's first of all, let's zero the file out. That makes it 0. In fact, let's do that. How do I zero out or create a new file? And that is just with this. You can do this. This works pretty much everywhere. So if you want to, that you can see now, if we cat the file, it won't have anything in it. And that gets you a zeroed out file. Now there was actually a really critical bug and what was it? It was a Go program that put a space in the wrong place, and it was deleting a file instead of fixing it. Yeah, you can also use touch. Touch is the common one. That's the one we taught last week. We already covered it. If you want to create a new file, you can use touch, but the important thing to do with touch is touch will also update the timestamp of an existing file. Okay, but if you want to put something inside of a script or something, you should probably stick with touch. But you can also touch will not zero out a file. Let's do this. Zero out a new an existing or new file. All right. So to create a new file, though, you generally want to use touch. how do I create a new file or update time changed? Okay, we'll put that there. I'll do touch. So how do I zero out an existing or new file? You can use that to zero that file out. And then you can, echo some temp foo, echo thing temp foo, and then you can cat the temp foo file out, and you'll see something. You see that it actually adds a line return at the end, which we'll get into that. But back to that teletype idea, right? Line returns, carriage returns, all that. We're going to get into that, but we won't get into that until we start scripting. So a pipe redirects. So just to summarize, a pipe redirects standard output by default and sends it to the standard input of another program, and that's why it's called a pipe, right? So a pipeline ultimately is just connecting the standard out from one program and or standard error, more or less standard out though, with the standard input of the program, right? So, and a lot of programs are written in the Unix way, in Linux and Unix, to accept standard input from the terminal, right? And when you send, those commands are sometimes called filters. We're going to get more into filters later, but and it's really hard. I'm really trying hard to avoid getting into the whole scripting thing right away. But there are multiple ways to get information into a program, right? You can do it through a pipe and send it to standard input. You can do it as an argument, which is just something, an item on the command line that appears after the command. And you can do it from an environment variable, but we'll get into that when we do the scripting. We need to learn how to edit files before we can do the scripting, and that's what's coming. So today, if the only thing you master today is how to navigate the file system and how to create files and add to files and manipulate files, then that'll be good. So the last thing too we need to figure out how to do is to remove files, and you can definitely use double quote if you want to. Z Shell has a bug. Z Shell has lots of bugs. Don't use Z Shell. Yeah, this boost does not cover Z Shell. If you're using Z Shell and you're hitting bugs, that's because you're using Z Shell. Okay, so for the most part, the stuff that we're talking about works everywhere. I am deliberately going to skip the reference to file descriptors in the redirect operators for now. Okay? Because beginners don't want to know that, right? Beginners just want to know, how do I write my stuff to a file? How do I put stuff onto the end of a file? How do I delete files? How do I create files? And how do I edit files? They do not yet care about all of this other stuff, right? And they don't know about commands that produce that other stuff. So I'm just going to put a thumbtack in that. So yeah, you don't need to know how to write standard error to a file, because that requires numeric indirection, and we're not going to do that yet. Okay, we're not going to do that yet. I don't want to give you too much too early, because that's gonna create problems. All right, so if you want to run ahead and learn how to redirect more than that, for right now, you just want to take this stuff from a command. We're keeping this very recipe driven, very, what are my needs, right? I want to be able to write to the end of a file. And, you can redirect different stuff here. I mean, if we want to, we could cover it, but I really, really don't want to burden everybody with too much stuff. So like, let's find an example of a command that would produce too much stuff to the... you know what? Let's do this. We're gonna do it. How do I find files with a given name, with a keyword in the name. Okay. Now we're going to be doing a bunch of searching later, and I don't want to overburden you with this right now. So we're just going to do the one command, and we're going to use find for this. Okay. And this approach of having one recipe per command line and putting that in your notes is very common. People have been doing that since the dawn of time. These commands, if you look at any one of these commands, and I'm struggling because I know what's possible with any one of these commands. I guarantee you everybody watching the chat and everybody watching the video right now has not fully mastered the find command. There are so many aspects of it, and so I hesitate to even introduce it to you, but the approach of putting down, I want to do this, and I want to know exactly how to do that. The kind of thing that would pop up on a Stack Exchange hit, right? That is the good way. That is a sustainable way for you to add to your notes. And then you can go to your GitHub notes, which we talked about on the first or second day, and you can go and organize them. But the reason that I am keeping it that way rather than telling you every single thing that you can do right away is because it will overburden you and you'll be like, yeah, I don't need to know all that other stuff. I just need to know how to do that one thing. Okay. And then you can add that one thing to a list of other things and you can grow, and you'll be continuing to grow your knowledge of Linux forever. You'll never learn it all. I promise you, you'll never learn it all. There's always more to learn, and you'll always be looking it up. So make sure that you have these questions and answer kind of approach in your notes. In fact, these answers that I'm putting here are not going to be in the YouTube show notes because I can't put them into YouTube show notes because YouTube is brain dead when it comes to angle brackets, these greater than signs, and I won't be able to do them. Okay, so with that caveat, I'm now going to tell you, with our remaining time, how to find files by name on the system. All right, this is probably, I think this is one of the most important skills anybody can have. It's also one of the most annoying things because the find command produces a lot of standard error. And so this gives us an opportunity to talk about some of the things people are suggesting in the chat about, well, what do I do if I'm getting too much standard error and I want to make it shut up, right? So it's leading to another recipe to come. All right, so how do I find files with a keyword in the name? Well, the first thing is, let's assume that you want to find in this directory, right? So the dot means this directory right here. I want to find I want to find a file that has a keyword in the name in this directory down, right? So that's what that first thing to find is. Okay. If you want to really read the nitty gritty of find, and you should, especially if you're a veteran, you should do man find and go read all about it. Okay. But I'm going to start you out small. All right. And then we're going to do -n for name. And then we're going to, this has to be in quotes. All right. So you can do single or double. I use single. And then you have to have a star so that unless you want it to match the beginning of the name. Right. And I want to look for all the Vim files, all the files that have Vim in the name. All right. That's it. That is it. So let's try that. So find dot slash, is it N or is it name? I might have spaced it because I was forcing myself to think about it. I might have it wrong. I actually think I might. Yeah, it is name. Yeah. Yeah, there it is. It's name. I'm sorry. I spaced it. I'm confusing it with my podman command. All right, so there we go. Dash name. And you notice this doesn't have two dashes, which is super annoying to me. But that's just the way find is. And that's that way on every single system. Okay. Just for fun, yeah, you could do, there are lots and lots of things that you might want. You might want to do case insensitive. I'm not going to go into that. So you can do case insensitive. You can do not. I like my cases to match. If you want to read about everything, you can. But as you can see, there are 1,400 lines of documentation for just the find command. So beginners, don't despair. Just know that, you can learn it a little bit at a time. So if you wanted to, instead of using, I will mention this, if you wanted it to be case insensitive, you could do I don't do that ever. I always do case sensitive, and then I want to find the ones that don't have it. Here's something interesting. If you do find dot, it will find everything in the current directory and all recursive directories down below that. I use this pretty frequently. If you combine this with a pager, you can actually see everything from here down. It's very, very comforting to do that. There are other ways to do this with ls, but they do not support it on all versions of Unix. So find space dot has, I think, has a very real place in my list of commands that I use all the time. There's an equivalent command called tree, which is a little bit prettier and that we've installed for you, which gives, a better, kind of a better thing to look at. But you don't always have that. You always have find dot usually. So you can use find dot and send that to more, and that will tell you everything. Now, this is where it gets kind of interesting. Okay, so far we didn't have any problems. There's other commands for finding things called locate and stuff. We're not going to do those right now. We're just going to focus on find. And so let's say I want to find where a binary program is, a program that's on my system, and I don't know where it is now. There are other ways to do this, like with which or something, right? But let's just say I wanted to go see wherever that file is. We could do find, but let's do find against slash. And now this is where things get really interesting because we don't have permission for everything, right? And we have a small container, so this should go pretty quickly. If it was on a big system, it might take forever. But let's do find dash name, and let's search for any. We want to find to see if this has the keg command in it anywhere. All right, and I actually know that it does not have keg command. So you see all those permission denieds? Guess where they got written to? They get written to the standard error. Now let's see if it's called Zet. Okay. Oh, look. So this is. So this time I tried to find. I tried to find all the files in the entire thing, in the entire computer. My container anyway, that have any Zet in the name anywhere. There's one there. How about KN? Let's try KN. KN. You can see. Oh, okay. So there's all the things that have KN in the name. Let's see if, this doesn't care whether it's an executable, and we can get into that. You can go so far. You can say, I only want directories and all that stuff. And we probably need to have just like a full hour to deal with find because it's so powerful. But with the boost being sort of a short thing, I wanted to just give you this concept. So if you do find Zet, but see how we have all these really annoying permission denieds, right? And this is one of these things that exists and is annoying everywhere, right? So if we do, we can actually pipe this, right? If we pipe it to more, what do we get? Oh, damn, we still got all those errors, right? So that didn't help. So what else can we do, right? Okay, so this is one of those cases where we need to redirect something, but if we redirect it, let's say, one of the things you could do is you could redirect it, maybe you thinking about this, let's redirect it to temp foo, right? Say, but Mr. Rob, it still did all those other errors, right? Well, what happens if I cat temp foo? Oh, look, it only gave me the one. So this is why we're doing this, because when you look at this, you can see that some of the stuff that's coming out of that find command is standard output, and some of it isn't. And you might ask, well, why didn't all those other errors get written to the file as well? And the answer is because only standard output is being redirected, right? And we can use that to our advantage. Now, that is a way for you to get the stuff that you want without having to know this more advanced way that I'm about to show you. So if you didn't know anything more than this, you'd be fine, right? This is how you want to redirect the standard output into a file that you care about. And now you got your list right here, and you can cat it and you can go look at it, right? But they're using, if we were going to do that with the pipes, let's say I don't want to, you can do this too, right? You can do more temp foo. You can go look at the You look at the file. Maybe it has a lot of stuff in there, right? In fact, we could make this, let's say every single file that has an L in it, right? And that might be a little bit more than we care to look up, right? So here's every file in the entire computer container that has an L in the name, in the file name. And that's the last part, right? There's a lot of them, right? So you might want to use your pager for that, right? But so again, you know how to do this without this extra stuff I'm about to show you. But let's say I want to do that same thing, but rather than putting it in a file and then looking at the file, I just want to send it right to my pager because I really don't want to have to make the file. So then you can send it to more, and you're like, oh, but now I'm getting this in there. What is that about, right? You know, you're getting a bunch of stuff, but you're also getting these errors that are like these gross errors in there, right? Let's go back to Zet so we can see those errors. But you can see you get those errors in there too, and you're like, ugh, right? So how do I redirect the errors? And this is a very common thing to do with find. The way to redirect the errors, I mean, we already know how to redirect standard output, right? We already did it, temp foo, right? And we do cat temp foo. You'll notice that the output is nothing there. So, but there's another way to redirect, and that is you can actually indicate the file descriptor that you want to redirect. So what if we redirected standard output to that, and we redirected standard error? We have to go look it up. Standard error is 2. So we say I want the 2 file descriptor to go to another file, temp ignore or something. All right. And now, whoa, okay, where did everything go, right? So let's go look at it. Cat temp foo. And we see that's there, and cat temp / ignore. And we see that's got all the errors. Now that is, imagine you have the 2 teletype machines, right? So we told all of the output going to the standard error to go, or file descriptor 2 to go to this other file. And we told all of our input to, you know, the stuff we care about to go to temp foo. Now, knowing what we know, so let me tell you about a special file for a second. Okay, so, I'm actually going to add it on here as we go. So a lot of people who know Linux are like, why are you doing temp ignore? Okay, what I'm trying to show you is that by sending standard error to temp ignore, we can ignore it, right? Now, and what if we had a ton of it and we really don't care about it? We just want it to shut up, right? We just want it to shut up. We just want to tell that content. Now, by the way, you could put 1 here too, you know, right? Because 1 stands for standard, you know, output. So either one of those are the same. But when you do standard error, you have to use a 2 because that's just not there. And it sends it to temp ignore. But let's say we don't care about it. So we can change temp ignore to be a special file called devnull. And devnull has a long, vibrant cultural history. Your opinion is rewritten to devnull, right? So devnull is a special file that is what's called a bit bucket, right? Anything that gets redirected there just disappears. It just obliterates it to death. And so I don't have to go back in and remove temp ignore. Let's actually cover that. How do we remove a file? So let's put that back on the list. Okay, how do I create a new file? How do I create a new file? How do I remove a file? Okay, so the remove command is rm, and we're just going to do that. All right, and we're just saying a file. We're not doing directories yet, just a file. So if you want to remove a file, you do rm just rm file, right? So if I wanted to remove temp ignore, remove temp ignore. You can look all about it, man rm. You can read about it and learn about it and stuff. It's a very dangerous command. People love using it as an example of how to destroy your system, but you have a container, so you're more or less safe. And yeah, so anyway, here we go. We're going to go back here. And so what we're trying to say here is if we want to make find quiet, right? Where's our find? So here's our find command. I push the. If you want to go back, you're going to learn how to search your history, but just push up arrows if you want to go back to your other command, and you say find whatever, right? So if we do that, now we can combine what we know, and instead of writing it to temp foo, we can leave the part that throws away the errors, and we can add our pipe back in here, and we can say I want to send this to more. And now we just get what we care about. And almost every time you ever see somebody use the find command, you will see this redirection. Now, unfortunately, it's not something you can easily alias. I wish it were. So there we go. So if you go to, if you go down here, you can say find, and you can say find dot name, and you can say to, make sure it's to, right? Dev null. And make sure you get dev null right, so you know how to redirect it to where it needs to go. And I think that there can't be a space there. I don't think there can be a space there. I'm questioning my reality right now. Let me see. No, yep, it has to be directly attached to the. I think you can have a space there, but not in the other one. Yeah, there you go. So, and I usually don't see spaces here very much at all for that kind of thing. Okay, so that's a lot to take in. That might be enough for today. So we've created files. The other thing to know is how do I remove and create a directory? So let's do that. So we've done this whole redirection thing is going to take you a while to get. So you should probably start practicing it, but you're going to see us doing it all the time. And I want you to be able to go back and forth between that so you know what's going on. Okay. And so you can actually, I suppose one last thing, how do I make errors? Let's see, how do I combine standard out, people want this all the time, and stud error. Okay, and you can probably guess, how do you do it, right? So we are going to send the output of one thing to the output of another thing. All right. Yeah. And there's two ways I can teach this to you, and I always struggle on this. I can teach it to you using the special devices, or I can teach it to you using the aliases for the file descriptors. All right, so let's go back to our command that's sending our stuff out, right? So now it's only showing us the stud out because we sent the standard out, the errors to dev null, right? And if we remove that, it's going to send the errors and both to our terminal, which is the combination of standard output and error in no particular order, by the way. So now we could do this. We could say if we didn't want it to go to there, we could actually, there's another special device. You may have already seen it. So if you do ls/dev, you can see that there are 3 devices here: standard in, standard out, and these are actually the very things that we're talking about. They represent those things in the kernel, and there's veterans who don't know about these. Some do, some don't. But what I want to show you is this. So you can look at these things, and you can see that they're special. They're special, and that they're symbolic links that point to the self proc FD0. Remember we talked about 0, right? And now we look at error. Let's look at that one. Oh, look, FD2. So remember we talked about 0, 1, and 2, and standard out is 1. So this is a little bit of a sneak peek into the special /proc file system, which we will cover when we talk about processes next week. So processes are running programs, and the self special process is the currently running process. In other words, our interactive shell. And so, or in this case, the command as it executes. I won't get into the process subtree right now, but so you can see that that the running process, so that any command that runs on the system can look at proc self fd0 and can get at, which has a nice happy alias called stud in, stud air, and stud out. So most people, when they teach you about these things, are going to teach you about the special syntax for file descriptors, which we'll get to. But what I want you to think about, though, is that those things are really just files, right? And they're files that are pointing to special devices, special things, special file descriptors. And you can think of it as those machines, those teletype machines, right? So dev stud in, you can think of it as our imaginary teletype machine keyboard that from which we read things. You can think of stud error as being a special, typewriter or teletype machine that's just for the out errors. And you can think of the out as another device that's just taking on all of the output. And you can think of TTY, the TTY, as we talk about, everything is a teletype, right? So anything that gets echoed to the TTY shows up on your screen, by the way. And so, but this idea of thinking of your terminal as a machine or as a device is going to be consistent throughout all of Linux and Unix. So it's probably good for you to start thinking about that right now. You remember that special device we talked about, dev null, where everything just goes away, right? Well, there's another couple of special ones here. There's random, and if you read from stud random, you get random bits. If you read from urandom, you get random bits. If you read from 0, you always get null bytes, which are just zeros, right? So these are kind of, you can think of these as actual devices. You can think of them as devices where if you went to go get something from that device, all you would ever get is zeros, or if you went to that one, you get a new random number every time. And so knowing what we know now about redirecting data, we can do this. We could say, okay, that's going there, right? We say, okay, we already know that if I want to get the errors to shut up, I can send them to dev null. Right? We did dev ignore first, then we deleted the file, but we don't want to delete the file, so we'll just send it to dev null because that's a dead file that doesn't ever have to be deleted, right? Okay, so that got rid of our errors, right? Here's something fun. What if I tried to what if I sent that standard error to dev standard error? Well, what do you know? It does exactly the same thing as nothing because we told it to do. That's exactly what it's doing. Right? That's exactly, it's doing that. It's sending the standard error to the standard error device, right? But what if we said, okay, I don't want it to go to the standard error device. I want the standard error to go to the standard out. Now what happens? Okay, well, we didn't see any difference. Why? Because it's all being written to the screen at the same time. But now let's try something else. Let's try to write that to our file like we did before, right? So remember, the default is standard output. So we're going to write the standard output to temp foo. Uh-oh, it didn't quite do it, did it? Didn't quite do it. Didn't quite do it. Or did it? Did it do it? I don't know. Oh, wait, I did the command wrong. I did the command wrong, didn't I? Pipe to the printer. You could pipe it to the printer. In the old days, we used to. Yeah, in the old days, we used to pipe it to the printer. We don't do it anymore. Okay, so it still wrote the right one. And I think it's because I have it out of order. Yeah, I think I have it out of order. I don't know. Let me try. I could be dead wrong on this. And I'm trying to... Oh, what the hell? Oh my gosh, it worked. Yeah, we're not learning any of those extra stuff yet. We're going to do those, but I want you to learn this in terms of files. I'm doing it this way on purpose, everybody. All the pros are telling me that I'm doing it wrong because they want you to learn how they taught it. But I'm trying to tell you that as a beginner, the best way for you to burn this into your brain is that all of this stuff is just file handles. They're just file descriptors, and we're dealing with them like files. Okay, so my mistake was what? Very common mistake, by the way. All right. I redirected the standard error before I redirected the standard out. And I took the standard error and I said, write the standard error as if it was going to go to the standard out. And then I redirected the standard out. And that didn't work. So what I want you to take away from this is that you have to do the standard out redirection first. Okay, it's very important that you get this. So you have to redirect the standard error first. Okay, I mean, sorry, the standard output. Standard output is the one that rules the day, right? So you have to do that redirection first. And so if we do this, wait, did I say it backwards again? I always get them wrong. I have to look at it. There we go. So we're redirecting, and if you wanted to, you can put a 1 here if you want. If it makes you feel comfortable, put a 1 there. Okay. So what is 1? 1 is standard output, right? And we're sending that to temp foo, and we're sending 2 to standard out. So we first of all redirect standard error, and then we redirect. First of all, we redirect standard out, and then we redirect the errors to standard out. So now they're both going. So where is this going to? Wait a second. Okay, so this is going to stat out, which is 1. So that all ends up going into foo. All right. So what you really want to know here is that when you go to temp foo now, you see it's all there. You see that? Now, what I find interesting, look at this. It made sure that the standard out was at the top and the standard errors are all in there, right? So that is the answer to the question. How do you combine standard error and standard? Now, there's a shortcut for what we just did. All right? There's a shortcut for that. So you don't have to do all that crazy stuff there, right? And the shortcut is, there's 2 shortcuts. There's one that's supported by Bash, and there's one that's supported by every Unix system on the planet, right? Okay, so if we want, here, I'm going to do the shortcut, right? You'll see this all of the time. Yeah, so here we have, we have 2 goes to standard dev out, right? Now, instead of saying dev stud out, we can say &1. All right, and that says redirect and that actually might have to come first. I don't know. No, that's fine. There we go. So there we have the same exact thing. And if we cat temp foo, you'll see that it's all there. It all got wrote in there just the same way. Okay. Yeah. So the takeaway from this is that you can use ampersand and the number of the file descriptor as a replacement for standard out, standard error, and or standard input, right? So this particular command will work on anything. I mean, it'll work on any Unix. Sometimes the order, you can get messed up with the order here. So let me just show you again. And I forget this all the time, and I keep second guessing myself even right now, because it's so easy to get the order wrong, right? It's very easy to get the order wrong. And so as you can see, so by the way, when you do this, let's say you don't want to write it to a file, right? Well, let's go back to our pipe again. And now we get all that stuff, right? We're getting back our errors. But if we wanted to redirect the whole thing, yeah, see, this is where you get problems, right? Because this isn't going to work. Why doesn't that work? It doesn't work because of the order, right? So we have to do it here. And then it'll do the right thing. All right, so that's been a really long-winded way of dealing with file descriptor redirection. But hopefully that'll answer that last question. How do I combine standard error and standard out? So the thing here is this. So, you could do name, let's say /name, I don't know, MD for like markdown or something. And then you would do, so, I mean, there's yet another way, and I'm going to show you that way right now. So you could also do, the and sign. Now this is not supported by anything but Bash, so I almost don't want to teach it to you. But should we? if you do this, if you do the special file descriptor, the wildcard, and you can it does both. All right, so that is the last thing to show you. All right, Uh, so if you're doing the ampersand, that automatically redirects standard error and standard out. It's very nice and fast, but that does not work on simpler shells or things besides Bash. And I think Z shell might support a fish. I mean, it's not. I don't believe it's a POSIX standard personally. I don't know. I could be wrong on that. Someone tell me I got it wrong. But if you cat temp foo, you can see that everything is written there as expected the same way. It's just kind of a shortcut when you want to write both standard output and the standard error, right? So I could have gotten rid of it and then I just get standard output. If I put the 2 there, I get standard input. I'm sorry, standard error, and then and is both, right? So people do use that for things, but it's not. Hey, how's it going? So that is one of the ways to do it. As you know, to write it like temp foo, and put a space there. So, but that is exactly the equivalent to the hard to remember this one, right? So you have to do the output first, and then you have to do the so 2, and you could do dev stud out, which is the same as ampersand ampersand 1. All right. Okay, so there we go. We have all of those different redirections. I didn't know if I wanted to cover that with you today, but I do think we need to cover it. Yeah. So here we have. Yeah, I like that idea. You can think of this as that. Or that. It's like, there you go. That's a good way to think of it. That's a great way to think of it, because you can if you want to think of it as numbers. I'm going to do this on purpose because it's kind of important that you remember that. But this is kind of fast way to do it. So you can omit the 1 if you want, right? But it's like 1 and then 2. That's a good way to remember it. I hadn't thought of that. Thank you for that. So you can say we can get rid of the 1 and it still goes to dev 2. Now this is misleading. Yeah, so I actually want to restate this. Let's say, how do I send standard error to stud out as well, right? So you can combine those two, and you can think of the numbers in order, and there you go. And then if you do this one, it'll do all of them. All of it will go to the same place. So the redirect operator. Yeah, I don't know. I think this is called the redirect or the override operator. I just call it output. When we read the bash man page, you could get the source of that from the bash man page. It'll use all the terminology properly. I think stud out, stud error, and you can also do this with append, right? So you just have to use the append operator instead. There are other operators. There's like the overwrite operator and the clobber operator and all this other stuff that you can use if you have no clobber activated. But we are not going to go into that. We will go into it when we read through the bash. We're going to learn bash thoroughly through the man page, which is very big. It's going to take us quite a long time to get through that. But this is the kind of stuff an absolute beginning user does need to understand, in order to redirect content from different sources. I'm feeling a little tired, which means you're probably feeling really tired too if you're a beginner. If you're chomping at the bit and you want to do more, you can fast forward and go ahead and do more, right? So, but that's all we're going to do for today. So for today, once again, the goal for today has been very simply getting the container to run so you have a command line, understanding what a prompt is, how to clear the screen, how to look around at where you are, how to navigate with CD and PWD, how to look at what's in a file using commands, how to manipulate the different file descriptors, what a file descriptor is, how to pipe from one thing into another. And that is going to become so important. When we start making Vim filters, you're going to see how powerful this combination can be. We have not done things related to searching other than find. Okay, so next week we're going to start by learning how to search for text inside of a file. In fact, we'll probably spend most of the day learning how to search for things. I think probably the single most important skill with regard to system administration is learning how to search inside of files and discover things. If you're a hacker, it's a super important skill. We learned the very beginnings of find today, so this will be a natural continuation. We will use find, but we're going to combine find with other things, and we're going to combine it with things that modify things, such as commands like sed and awk and grep and all of these fundamentals. When someone thinks of Linux or Unix, they almost immediately think of sed, awk, grep, and bash and those kind of things. So these main high-level commands always go together. And sometimes they're not the best choice, and we'll talk about why that's the best choice and when it isn't the best choice, when it is and when it isn't. But you have to understand this entire idea of file descriptors, standard in, standard output, and standard error. Otherwise, all of the rest of the conversation about finding things and filtering things and grepping things out of files is going to be irrelevant. And some of you may be wondering, well, I still don't know how to edit what's in a file. And I'm doing that on purpose because I want you to get good dealing with files without using an editor yet. Okay, because opening up the file and just moving around with it with an editor is good and all, but that is generally not always available to everybody. So you need to get good with manipulating files and seeing what's in them, and even creating new ones and modifying what's in those files without even using an editor. Right? That's an essential skill. You really, really need to learn that. And the reason we're learning it first is because if you learn how to do that, when it comes time to use ed or vim or any of your preferred editors out there, it'll be a cinch, and you'll immediately understand why you learned those things first, because those editors are built on top of the system that we're going through today, the system of redirection, indirection, and piping and all that stuff. All of the editors that have ever been built, they were invented after all of these other things existed. And so it's good for you to learn how to manipulate the system that way. And then when it comes time to script, believe me, I have a method to this madness. When it comes time to script, you'd be like, well, damn, now I don't need an editor. Otherwise, I would have had to have an editor to make that change to the file. But I already know how to make that change to the file because I learned how to edit files and manipulate them before I could even use an editor, right? So if you think about these ways of manipulating files first and foremost in your brain, before you even touch an editor, you'll be like a rock star scripter, because everything that you learn to do in a pipeline on the command line can now be transferred into a file and become code. It can become a script. And frankly, every time you execute any command on the command line, you're already writing code. And we're going to talk about that again, too, in about 2 weeks. So, you can do massive file replaces with sed. Next week is going to be how do we look for things inside of these files, right? And I don't know if we're going to get to it next week, but then the step after that is going to be how do we change and how do we write files through just using this method. And then it will be, let's use an editor and make a direct change. Okay, so that's it for YouTube today. And you can use Python too if you want to. We're going to talk more about this later. Hopefully you've been patient with us. Every single boost is a little bit different. And that's never going to change. It's always fun that way. It depends on our input. And every time we learn to cover things a little bit differently. So thank you for your patience there. If that's not your style, I'm sorry. There's tons of other content out there, but this content's free for the most part. So thank you for your input. Thank you for your comments. Do that whole like and subscribe thing. Tell your friends. If you have specific questions, please let us know in the Discord. And we'll adapt and we'll make changes to make it easier for you, such as making you a container you can use. So as you exit out of your container, make sure that you just, that you go ahead and just type exit to get out of your container. You can just type exit here, and that will take you out of your container, and your container is still there for you for the next time. And again, to restart and connect to your container, podman start-a boost, and you should be able to get back in. Oh, whoops, you might have to type, I had too much running. Take that back. So there you go. And we're back in right where we left off, and we'll talk to you next week.